Mathematics, Advanced Subsidiary Level, Paper 1, 2024, Part 3. Question number 6. A function f is such that fx equals 2x to the power 2 minus 12x plus 4 for the domain x is bigger than equal to 0 and smaller and equal to 5. Express fx in this form, where a, p, and q are constants. Okay, now where will I find this in the textbook? Okay, so you can look there at maximum and minimum values of quadratic functions. And you will find that on page 21 and page 22, example 22 and example 23. That's going to help you. That you will find in the y equals mx+c mathematics textbooks. Okay, let's start. First, let's write down the expression part. So 2x squared minus 12x plus 14. Okay. So if I take out 2, I can write it like this, fx. Remember, it's not an equation. We just use this part, just the right-hand side as an expression. So I take 2 out as a common factor. So it's x squared minus 12 over 2, because I take it out as a common factor, plus 14 over 2, and there I leave that spaces. Okay, now just to stand out, I'm taking this is 6 and I divide it by 2. Always the middle term be divided by 2. So this is I'm just going to use another color that you just see this. So this is plus 3 squared. And then whatever you add, you subtract. Okay. And now you're going to keep the 2. There. Factorize that. That's now perfect square. So this is the x, that sign, and the 3, and the square. And there I simplify. That's 7 minus 9, and I close the bracket. So 2... then it's x minus 3. Okay, I'm doing this, I think you could have do it in one step. Now I multiply, but just multiply it in front of the bracket. So it's going to be 2 x minus 3 squared minus 4. And there I was putting it in that form. Okay, let's go on with B. Find the range of fx in this domain. But now be careful, it's not open. It's having as a restriction on that domain. So where do I find this in the textbook? So find the domain and range of functions. What I want to say, if you have the textbook in front of you, the y equals mx+c, always just go to the beginning of the textbook, the index, and then look for that sentence, and then you can also go to the pages. I just did it now for you. So if you go to page 103 and you look at example 5, that is going to help you definitely. Okay, but let's start. Out of this, I can find the turning point. So I know that the turning point, I change that sign, so it's positive 3, and I keep that. That's the turning point. But I still want to get 0, what is the y value, and 5, what is the y value, because it's included. So if I go f0, and you can just substitute it in that, so it's going to be 2, and then it's 0 squared, minus 12, 0, plus 14, and that is equal to 14. And if you say f5, that is going to be 2, and then it's going to be 5 squared, minus 12, 5, plus 14, and that is going to be 4. Now it will be good if you make just a sketch, just to help you. Okay, so let's just do that sketch, just to fill in that 3 points. So the first thing, I just want to make that line. I don't like lines that's not straight, okay? And I don't want to make it, I want to keep it to green. Okay, so basically, I'm just going to mark that point. So let's mark the point. Let's say 3 and 4, okay, and negative 4. So let's say it's there. That is 3 and negative 4. Okay, it's just a sketch. Then, if the value of x was 0, did you see? If the value of x was 0, then the value of y was 14. So 0, and then the value of y was, say, 14. So 0, 14. And then when the value of x was 5, then the value of was 4. Do you see? Okay, you can even write it if you want. You can say it here, 0, 14. And this one is 5 and 4. Okay, so this one will be 5 and then it will be 4. Say, for example, there, 5 and 4. Okay, and now if I draw that, okay, let's just use another color. I think so. Let's just do this. So if I draw this, okay, and it's cutting the y-axis at 14. Yes, there. So if I draw this, okay, doesn't matter, there. Now, what I want to see from this sketch, I just want to see, okay, no, let's just go. It must stop there. It must start there and it stopped there. Do you see? So basically, I want to see, just on the y, it was reaching 14. And what is the lowest point on the y? It was negative 4. Do you see that? And that's the two values that I'm interested in. So if I'm going to say the range, then I'm just going to say y is bigger and equal, because the turning point is included, so negative 4. And then again, that's an equal sign there at 5, so smaller, actually at 0, but still, okay. And then 14. And that's how I did that. Okay, so remember, get the turning point, and then the next step, get the 2 points to find the coordinate points of this. And then, so can you see, this one was not really helping you, but you look for the one that extreme values. This one, extreme y value was 14, and the extreme lower value was negative 4, and then you just basically fill it in. Okay, and then the last one, another function g is such that this, but now take note that this g, always compare it. If you see you are coming to a value of c, then look up if the value of b or a must not help you. So you can see that part was the same. But that is now just for x smaller and equal, so they just bring another restriction in there. Find the expression for the inverse. Now, you can, okay, again, where will you find this? You can look, there's a nice example on page 112, example 13 in the y equals mx plus c, and it will also help you, especially with the last part. So basically, if you want to find the inverse of a quadratic equation, then it must be in this format. So you're going to use a. So basically, you can start with gx and then say 2x squared minus 12x plus 14. Okay, well, let's just go plus 14. But now you must put it first in that format, okay, because that's exactly the same. It's just the domain that's different. So you must have it in this format. Okay, then you can find the inverse. Then you can say, okay, I make this y, and I make this xy, so the x becomes y. Okay, now let's first, before I do that, sorry, I just want to I will now swap it. I just want to make the gxy first. Now the y can become x and the x can become y. Okay, now I can make y the subject of the formula. So it's going to be x plus 4 and then it's going to be 2 y minus 3 squared. And then I divide by 2 and I divide by 2. So I'm getting, and then to get the square root away from that side, I'm going to say plus minus, first plus minus, I'll show now how we decide which one. X plus 4 over 2 equals y minus 3. Okay, now I'm going to swap the sides. So I'm going to keep, so if you take the 3 over, it's going to be plus. So if I swap the sides now, it's going to be 3 plus minus x plus 4 over 2. But now, this is very, very important, and it stands in the textbook in example 13 at the bottom. But, and I'm writing it here, but, because x is smaller and equal to 3, not bigger and equal, then the inverse g minus 1, and I forgot, I should have wrote the last step. I could have just here, the last step, I will do it in the last step. I'll do it in the last step. G minus 1, because there is a last step, will be y is smaller, and it will be the negative option. Otherwise, it would have been the positive option. So, therefore, you must end g minus 1. Now I'm putting it correct. And it must only be 3 minus, not plus minus, x plus 4 over 2. That was the final answer. But let's go again to the examination report. Okay, so in the examination report, they are saying the following for number A. This question was well handled by most candidates. Completing the square is a concept covered at ordinary level, and it's not expected to give learners at this level some problems. It was also seen in some candidates that they failed to introduce the square and left their answer as that. Okay, but at the end, it was this, just as we got there. Can you recall? So if you got it in that, I think they were focusing. They go for the 2 a mark, they go for the negative 3 a mark, and the negative 4. So that was the 3 marks. Okay, number B, it was fairly answered. A number of candidates got F0 equals 14 and F is 4. So they got that and concluded then 4 and 14, which is not correct. You must make a sketch and bring in the 3 points. That 2 plus the turning point, and then decide which one of the 2 is giving the extreme values. They did not realize that the turning point was included in the given domain. Others only wrote this 14, while others only wrote this. But at the end, when you're making the sketch, so they already gave you a mark. If you come to that 2 values, you got your 1 mark. But then sketching it and coming to, then that was your other mark. Okay. So 1 was the turning point, indicating the turning point. And this one was the turning point, and this one was using this. This one is in the middle. Okay. So then the next one, the last question. Let's just look at the last question. Let's just make it bigger that you can see better. Okay. So this was also fairly answered. Okay, what they say. Some candidates did not realize that the form for C was supposed to be used. So always look up to A or B for the inverse. They could see that G shared the same function but with different domains. Those who got the inverse correct missed the final mark by wrongly stated the plus or the plus minus or the plus, but it was just the negative. Okay, and I showed you why. So due to the domain that was smaller. So basically, if you got that, if you got it in that form, for interchanging the x and the y incorrect. So if they saw you did that, they gave you a mark, and then only for the final answer, which is only the negative part. Question number 7. Two circles C1 and C2 touch each other at point P. Circle C1 has center R and radius 9. Circle C2 has center Q and radius 4 centimeters. Points S and T lie on C1 and C2 respectively. The line ST is a tangent to both circles. Okay, and then they start. So before we start, where will we find? Because they say show that angle SRQ equals 1.176 radians, correct to 3 decimal places. Okay, now before we start, this is, let's find the topic. This is circular measure. And you will find an example in the y equals mx+c mathematics textbook, example 57, page 213. That will help you. But before we start with the question, let's first see what information we can add to the sketch. So if this is 9 centimeter, we can also go and say that this will also be 9. That's also a radius. If this is 4, then we can say PQ is also 4. Okay, this is a tangent ST, so we can say that this is 90, angle between a radius and a tangent. Between a radius and a tangent, this will also be 90 degrees. Okay, now we can start with the question. Now, if they say show, now first what we're going to do is we're going to see if we can create a 90-degree triangle. Okay, so if we make a line there, then we have also 90 degrees there. We also can say if this was 4, then this will be 4, and that part there will be 5. Okay, so I'm sitting now with my 90-degree triangle, if you can see it there. So there and there. There's my 90-degree triangle. Now, out of that, then it's easy to find an angle. And I'm looking for this angle, that angle there. Let's just make it a curve. That angle there. Okay, so the triangle that I'm looking at is that yellow triangle. Now, if I look at the yellow triangle, remember that this side is now 5. So I'm looking for that angle. That is the adjacent. This is the opposite, and this is the hypotenuse. So if I think of adjacent hypotenuse, I'm going to use cos. So I'm just going to use basic trigonometry. So I'm going to say cos of angle SRQ, and that's adjacent over hypotenuse, so it's 5/13. Now remember, it's in radians, so make sure you put your calculator, press it on radians, okay, on R. Now press on your calculator, shift cos bracket 5/13, close the bracket. Now always with trigonometry, so we say angle SRQ, we first always write the full calculator display. So it's 1.176005207, especially if they ask that we must prove this. And then we can end with 1.176 radians. Okay, now remember, this was very nice set up by the examiners, because you're going to use this answer of A, maybe, because this is usually why they do it, in the next question B. Then please, if you didn't come to the correct one, ignore your incorrect one, but continue with the correct one that they are giving you. Okay, so let's continue the question. Let's see on the next page. Find the area of the shaded region. Okay, let's go back, okay, because our sketch is here. Now, if I go and I extend this yellow lines, if I extend this yellow line here, and I extend this yellow line there and there, can you see that that is forming a trapezium? There is my trapezium. Then this yellow RQTS or SRQT, doesn't matter, just go clockwise around. But if I then go and I subtract sector, okay, let's just, if I take this sector, do you see that area, and I subtract it, and I take this sector, this area, and I also subtract it, then I'm left with the shaded, okay. Now, if I must look what is the area of a sector, I'll show you now on the formula sheet. The only problem is I have that angle. Don't forget that that angle is now 1.176 radians. Okay, but I must still find this angle. Now, there's two ways of finding this angle. I just do the talking, then we go back and we do the writing because we are on different pages. If I extend this line, if I take this line, I just want to go to yellow, and I extend this line, then I want you to see this is corresponding the Z angles. Then I know that this is parallel to this. So basically, there is my Z. Do you see my Z? So I can basically go and say that this angle, I just want to make it better. This angle will be equal to this angle. Parallel lines, corresponding angles. There is my Z. Do you see my Z? Okay, there. So if I know that this is 1.76, then I can know that this one here will also be 1.176. But that's not the one I'm looking for. I'm looking for this one. But I know that a straight line is pi. So I can find this one by just saying pi, a straight line, minus that 1.176. That is an easy way to do it. The other way which you could have, it's not the way I did, but I just mentioned it, is that you could have worked out this angle. Now, how would you work out that angle there? You will also use this 90-degree triangle and just work with this angle. Opposite 5 over hypotenuse, sin. And then if you have this little green, you know that this is a 90, so that will be a half pi. And then you will just add that little one. But maybe that's a longer method. I think this one, which I showed you there, will be an easier one. So let's go to the next page and let's start doing the stuff. I'll come back to this page. Okay, so basically, before I start, let's just go back. If I want this yellow, the area of a trapezium, I still need something. What do I need? I still need the height between the parallel sides. I don't have it. But again, I can work it out in this triangle, the 90-degree triangle, with Pythagoras theorem. So that's the first thing that we're going to do, is we're going to get the height of the trapezium. Okay, so the height, just want to go to blue. So the height of the trapezium, and that is now, because it's a triangle, can I just go back? I don't mind going back. So there, it's going to be, this one is 13. Can you recall? This one is 13. And this one is 5. So it's going to be the long one square minus the short one square. So it's going to be 13 square minus 5 square. And that is going to be the square root of 144, because it's 169 minus 25. And that is going to be an answer of 12. Okay, now I can go and start working out the shaded area. So I can say the shaded region okay, let's just see what I'm going to do. I'm just going to put it here. It's going to be the trapezium minus sector 1 minus sector 2. Now, what is the area of a sector? I know what is the area of a trapezium. I'll show you now. Half height, sum of parallel sides. That you must recall from early grades. But what is this formula of a sector is on, and I think I already highlight. Go to your formula sheet at the back. Okay, there are already. So on the first one, the area of a sector, do you see it's half r squared pi? Do you see that? And it must be in radians. Okay, half r squared theta. Sorry, not pi, theta. Okay, so let's just go back. Okay, so I'm just going to say it's going to be a half. Okay, can you recall the formula? Can I just write it down for you? So it was, okay, the area of a sector is a half r squared theta. Okay, so it's the r of the first one, that's all right. I have that square, and that is the value I was working out or proving, 1.176. Okay, but the other one, now I'm just going to, it's the 4 radius, but that is the one which we said we will take a straight line and we will just, the corresponding angles, subtract that 1.176. Okay, now work out on your calculator. Now I like to rather write this step, not to make mistakes. I work everyone separately. Okay, so I didn't show you here. I would just like to show you first this one. Sorry, it's a bit long now, but I wanted to show you this also. So the height was 12 and the parallel sides was 9 plus 4. Okay, and the rest was just now, sorry, I'm just rewriting. You don't have to put in this step, but I think for the video it's important, and I'm just going to keep it because I press it in on the calculator like that. Okay, so this is going to be 78 minus 47.628 if I press this on the calculator, and if I press this on the calculator, so it's 0.5 times 4 times 4 times bracket pi minus 1.176, close the bracket, equals, and that is going to be 15.7247413. And again, first your full calculator display 14.64725,877, and that is going to be 14 to 3 seconds. Okay, 0.6. Okay, let's go to the exam report. Okay, so on the exam report, if I'm looking on the exam report, what are they saying? They say this question is moderately answered. A number of candidates struggled to see that the equation required them to use the primary trigonometric ratios. They went on to use the cosine rule, the sine rule, or some other candidates' complicated options. In many cases, they could not establish the quoted answer. In questions of this nature, candidates are advised to write their full calculator display before stating the quoted answer. Very important. Those who wrote this and this could not obtain full marks. Okay, so basically what they are saying there, if you did not write that full calculator display, then if you just went from this step to this step, you only scored 1 mark. So especially if they say show that, but it's best to do it always. And then the next one, it's moderately answered. Majority of candidates only calculate the area of the sector PRS, which was easy, and wrongly calculate the area of the other sector because they had to work out that angle. There were a few candidates who missed the accuracy of this answer by premature rounding their part answers to free significant and then used the rounded answer to calculate the final answer. Answer used in the working should always be rounded to more than 3 to avoid premature rounding. At least if you just do it to 4 or 5, I think you can be accurate, but best to just write it down. Okay, so the area of the trapezium was this 78. So if they saw that you got the area of the prism, then they gave you a mark. They saw you got the area of the one sector, they gave you a mark. For the other sector, a mark. And then for the final answer, your last mark.
Exam tips!
Let's check your answers.
I tried 2 different methods. But then I realized my mistake. So I tried again. So my final answer is 6.
Wait, Anna, you can't leave both methods. You should delete the wrong one.
Upi is right. If you leave multiple methods, the examiner will only mark the first one, even if it's incorrect. Always cross out mistakes so your correct work is graded. Lesson learned?
Only keep the correct method.